Hello GeoTriggers, this is the last video on graphing transformed trig functions. I'm going to be working on number 5 from your notes yesterday. This is a tangent function, so it's good to start with looking at what the tangent parent function would look like. And here it is from our notes last Friday. Okay, so here's a parent graph of a tangent function. Notice that tangent functions do have a different period, only 180 degrees or pi. 5 key values are 0, 1, undefined, -1, and 0. So let's translate that over to our chart. 0, 1, undefined, -1, and 0. And that stretches from 0 degrees out to 180 degrees. So each stopping point would be 45-degree increments. Okay, so here are my parent function values of tangent. All right, I want to apply all the parts of this transformation, and this one has everything present. Let's start with the y values. Again, this is really not a great representation that I've written here in the table. There is no amplitude of tangent since it's not a wave function. A better name would be vertical stretch. The a value of tangent is 3, so I'm going to take every y value and multiply it by 3. 0 times 3 is 0. 1 times 3 is 3. Undefined times 3 is still undefined. -1 times 3 is -3. And 0 times 3 is 0. Next, I want to apply the vertical shift, which is represented by the d value, this +3, which means I'm going to add 3 to each of the y values. 0 plus 3 is 3. 3 plus 3 is 6. Undefined plus 3 is undefined. -3 plus 3 is 0. And 0 plus 3 is 3. So the vertical shift holds the finalized y values. Now to work on our x values. First, we want to apply the period change. The formula for transforming a period is that the transformed period is equal to the original period divided by b, which in this case would be 180 degrees divided by 2, the b value present in the function, which equals 90. So this function's being squeezed or compressed horizontally, and instead of reaching out to 180 degrees, it's going to reach out to 90 degrees. So now the increments between each function are half as big as they were. Or you can think, whatever I did to the x value here, I have to do to every x value, which is divide by 2. 45 divided by 2 is 22.5. That's going to be a tough one to graph. We're going to have to think that one through. 90 divided by 2 is 45. 135 divided by 2 is 67.5. Another tough one to think through. Now we're going to work on our phase shift. Phase shift of a transformed function is equal to c over b. Our c value is positive 180. Again, that minus is part of the function. And the b value is 2. So this entire function is moving right 90 degrees, which makes us add 90 degrees to each x value. 0 plus 90 is 90. 22.5 plus 90 is 112.5. 45 plus 90 is 135. 67.5 plus 90 is 157.5. And 90 plus 90 is 180 degrees. So the phase shift column and the vertical shift column are the two values that I'm plotting. Now some of these are going to be tough to plot. I can find 90 degrees, that's marked well, so over 90 up 3 is an easy point to plot. Let's skip this 112.5 for a second and move over. 135 degrees is exactly halfway between 0 and 180, so it's this third line to the right of the y-axis. And its y value is undefined, meaning there's an asymptote present here. 157.5 might be tough to plot. Let's come back to it. 180 degrees is easy to find, and the y value is 3. Okay, so let's see what's going on here with these decimal values. 112.5 is exactly halfway between 90 and 135. This one of these blocks is 45 degrees. And the difference between each of our x values is 22.5 degrees, which is half of 45. So this 112.5 is halfway between 90 and 135. So I'm plotting my point here. Over 112.5 up 6. Something similar is true about 157.5. It's exactly halfway between 135 and 180, or 22.5 degrees to the right of the asymptote. Okay, so if those points don't look like they're helpful to you, go back to what the tangent function looks like. Okay, take a look and see if you can find it in what you've graphed here. I need to go up towards the asymptote and down towards the asymptote. This would be one full cycle of tangent. To complete the pattern, notice that every half block I'm plotting a value of tangent, a key value of tangent. So a half block to the right should match this y value of 6. A half block to the right of that should match another asymptote. This is pattern finding. A half block to the right of that should start another wave, so down here at 0. A half block to the right of that should match this value of 3. A half block to the right of that should match the value of 6. A half block to the right of that is another undefined value, so another asymptote. So keep going, creating as many tangents as it will fit on the graph. I'm going to put my asymptotes in first. Well, that wasn't a very good wave. I'm going too fast here. There we go. Slow myself down, get the wave in there. That's a little bit better. Now going the other way. Remember, half blocks is our iteration here. Whoa. All right. This is a pretty intense tangent graph here. Very compressed. We've got a lot of cycles represented on this graph, but that is a complete graph of this transform tangent function.